How do you do? Gerhard von Mohl here. I spend a lot of time underground. And when it comes to digging, I'm something of an expert. But, I'm not the only one digging down here. Lately, it's been getting crowded. These people are drilling for oil. The hard part is they do it from the surface. Now, when I dig, it's pretty easy. I mean, I just go where I want to. I dig around and through any obstacle I might find. But when my friends up there dig, it's a little different. They're all concerned with efficiency, expenses, and things like that. So, they usually try to drill straight holes, like this. You know, the shortest distance between 2 points. But sometimes keeping the well straight isn't so easy. A lot of things, like different types of rock, for instance, can turn the drill bit away from a straight path. So sometimes they use stabilizers and other tools to try to keep the bit on a straight course. Not bad for amateurs. Amateurs? Come on. Did you say amateurs, Gerhard? Ah, my friend, the drilling expert. He's back. Well, it's not that we don't trust you, Gerhard. It's just that we'd like a little more informed opinion on this particular subject. Informed? For instance, you take straight hole drilling. You're right, it's important. But sometimes, I was just about to get to, as I was saying, drilling tools get stuck down hole and can't be retrieved. And sometimes we find oil in hard-to-reach spots like under cities. That's when straight hole drilling isn't practical. Then we have to curve the well. I was just getting to that. Curve it or deviate it just enough to bypass the problem. Now, we call this planned curving of wells or controlled directional drilling. Yes, controlled directional drilling. Are you going to keep this up all day? Well, certainly. A little help now and then never hurt. Oh, of course, of course. Now then, where was I? Oh, yes. Directional drilling comes in handy whether it's used to correct a curving well bore that should be on a straighter course or used to drill a number of different wells from one rig, like they do offshore. Offshore drilling is expensive. The platforms and rigs cost a lot of money. But directional drilling makes it possible to drill up to 40 or more wells from a single platform. Of course, directional wells are used for other reasons, too. Probably the most dramatic is killing an uncontrolled well. The directional well is drilled close by the blowing well and deviated toward the reservoir. Mud is then pumped into the well until it has been brought under control or killed. To deviate or curve the well, a directional driller can use one of three basic patterns. First, he can deflect the well slightly at a relatively shallow depth, and then drill at a controlled angle to the production zone. This plan gives the driller the shortest and most economic path to his target. Second, if he's offshore and trying to angle several well bores into a reservoir, or if the hole runs into some troublesome formations, he can deviate the well twice, once at a shallow depth and then again just above the reservoir. And third, he can keep the well straight until it's almost to the reservoir and then deflect it into the pay zone. This type also helps him avoid troublesome formations. But whatever type the directional driller uses, it's important that he control the deflections and keep the well bore on a planned course. Excuse me, a planned course? You mean you actually do some thinking ahead of time? Back again, Gerhard? Before a directional well is drilled, the directional driller and company plan the entire course of the well. Well, you should know that. They make a horizontal and vertical outline of the well's path. They take into consideration things like location of the desired target, rig capacity, hole size, mud program, types of formations, and casing program, and plan the most economical course. Once that's done, the directional driller drills the hole as straight as possible until he reaches the point where the deflection begins. Then, according to his plan, he starts the deflection from what's called a kickoff point, or KOP. From there, he builds the angle slowly, usually less than 5 degrees per 100 feet, until it reaches a specific number of degrees. He also angles the well bore in a specific direction. Once the angle and direction are set, the part of the directional tool that faces this new direction is referred to as tool face. Now then, after the deflection is made and the tool face set, the driller continues in as straight a line as possible until he reaches the desired bottom hole target, or until he reaches a point where the path must change again.
Yeah, and what if the angle of the well bore increases more than 5 degrees per 100 feet, like this, huh? Or he inadvertently switches direction. I've seen it a million...
Yes, you're right. Sometimes that does happen. Whenever there's a sharp, unintentional change in angle or unintentional change in direction of the well bore, the driller could have a problem. This change in angle or direction is called a dogleg, and it's something he tries to avoid. A sharp dogleg like this one can wear out the drill pipe and sometimes get it stuck down hole. And too many changes in direction are time-consuming and costly. So, a directional driller tries to limit the rate of change in angle to less than 5 degrees per 100 feet and keep the well bore as close to the proper direction as possible.
Oh, that's much better. Accuracy is most important, you know, particularly for you.
Now, once the driller has a plan for his directional well, he'll need special tools to help do the job right. Let's look at...
Tools? Did you say tools? Oh, have I got it? I do have a small collection here.
Gerhardt, I think we had something a little more sophisticated in mind.
Sophisticated? Well, of course.
For instance, the driller needs special drilling tools like these that will drill the directional hole. And he needs survey instruments like these to help him keep track of the angle and the direction of the hole. Now, survey instruments help the driller see from the surface the exact angle and direction of the well bore.
Exact, you say? And how do you do this?
Well, some of these instruments use photographic equipment, a magnetic compass floating in liquid, and a timer. And others use gyro compasses and pendulums with the photographic equipment and timer. But both types do the same thing. A camera takes pictures of the compass at different depths and records the angle and direction of the hole in relation to magnetic north. By using these instruments, the driller plots the actual course of the well and compares it with the planned course all along the way. Now then, besides survey instruments, the driller uses special types of drilling tools to drill a directional hole. One of these tools is a downhole turbine motor. The turbine motor uses only drilling fluid to rotate the bit, not the rotary table. The mud flows through the stationary drill stem and across the fixed stator blades. The stator blades direct the flow so that the mud is channeled onto the rotors. The rotors then turn the shaft that rotates the bit. This action allows the drill stem to remain stationary. This is important when drilling directional holes. You'll see why in a minute. Another downhole motor, the positive displacement motor, is one of the most commonly used directional tools. The positive displacement motor uses an unusual spiral-shaped rotor. The motor is operated by pumping either air or drilling fluid down past this multi-curved rotor, forcing it to turn. The rotor then, through a connecting rod assembly, rotates the bit. This motor also allows the drill stem to remain stationary.
Positive displacement motors, turbine motors. Pretty fancy.
Yes, they are. But there's one important problem with both these motors.
Problem? I don't remember.
That's all right, Gerhard, I remember. Both motors produce an effect called reactive torque.
Reactive what? Here it is. Reactive torque refers to the tendency of the drill stem to turn to the left when starting the downhole motor drilling operation.
Yeah, that's it, Gerhard. Reactive torque takes place as the mud flows through the downhole motor. Since the bit is being turned to the right, any opposing force against the motor will cause it to turn counterclockwise or left. This reaction is then transferred to the drill stem, causing it to turn left and causing the tool to drift off course. In soft formations, the drilling tool can drift to the left as much as 10 degrees every 1,000 feet, while in hard formations, it may drift only 5 degrees every 1,000 feet. But no matter how small the drift is, the driller must take it into consideration when planning the course of the well. Now, in addition to downhole motors, there are other tools drillers use to drill a directional hole.
What? I thought these motors would take care of all your problems.
Well, not all. You see, most motors by themselves will not start the deflection of the hole. They won't kick off vertical by themselves. One way to do that is to lower them into the hole on a bent sub or in a bent housing, one that's already deflected at an angle from 1 to 3 degrees.
Well, won't that create just a bit of a problem for you?
Well, yes, that's why the driller must be careful when lowering the motor and bent sub or housing into the well. A bit made up on a bent sub can sometimes dig into the sides of the hole and get stuck. Now, an alternative tool is the flexible joint. It's also used above the downhole motor. This joint can be lowered into the hole in a straight position and then kicked off vertical on bottom. The driller can also use the flexible joint with the bent sub or housing if he needs to for extra effect. Now then, bent subs, bent housings, and flexible joints allow the driller to face the downhole tool in a certain direction and maintain that directional tool face as he drills. Now, this fact is important. Why? Well, remember, the downhole motors allow the drill stem to remain stationary while only the bit rotates. If you face the sub or joint in a specific direction with only the bit turning, then the well bore will follow the new path that is set. But if the bent sub or flexible joint is lowered into the hole and the entire drill stem rotated, then no new direction is taken. A straight hole is drilled instead.
Oh, nice work. I could use one of these. Let's see. Bent subs, flexible joints, specifically developed for use with any downhole motor.
Gerhard, if we could continue. There's more.
More? Now what?
More deflection tools. The driller can also use what is called a jet deflection bit to deflect the well's path or kick off vertical. This bit has one large nozzle and two other nozzles that are much smaller or are blocked off entirely. When drilling with this bit, the driller begins by raising and lowering the bit instead of rotating it. At the same time, drilling fluid is forced out the larger nozzle at a higher velocity. The fluid washes away more of the formation on one side of the hole than the other. The driller continues the jetting procedure until it has established a new course. Then he continues with normal drilling procedures. This type of bit can be very useful in areas where washing the formation is possible. Another deflecting tool that is sometimes used is the whipstock. The whipstock is a wedge-shaped tool with a tapered groove on one side. The groove guides the bit into the wall of the well bore at an angle to start the deflection. Because the whipstock occupies a major part of the hole, it uses a less than full gauge bit. The smaller bit drills past the length of the whipstock, 15 to 20 feet. Then the driller retrieves the whipstock and drills a full gauge hole. Drilling only 15 to 20 feet at a time is a big disadvantage. Another disadvantage is that it takes several trips to orient the whipstock or face it in the proper direction. But even with these disadvantages, the whipstock is used at great depths where high temperatures might harm some of the other deflecting tools. They are also used where a casing whipstock is necessary. Now then, once the deflection is started and the desired course established, the downhole motor or other deflector can be pulled and stabilizers used with a normal rotating drill string to maintain the course. The stabilizers can also be used to increase or decrease the angle of the hole. For instance, if the driller places the stabilizers just above the bit, the drill collars bend toward the low side of the hole like a fulcrum and push the bit to the high side of the hole. Drilling with stabilizers this close to the bit increases the angle of the well bore. The driller places the stabilizers farther up the collar from the bit if he wants to decrease the angle of the hole. Gravity helps pull the bit to the low side of the hole and forces the drill stem to straighten it.
Oh, Himmel! We have covered a lot of information here. Do you suppose a bit of refreshment is called for?
Hey, good idea. Hey, why don't we stop the cassette, change trays, work exercise 1, and maybe take a short break. Okay, Gerhard, now that we've seen the different drilling and deflecting tools, let's look at how the driller uses these tools in a typical directional well.
Aha! Well, at last, some concrete examples. Perhaps you would like me to help?
I'll call if I need anything, Gerhard.
Call? Am I going somewhere? I'm here. I have my books. I'm ready.
Where was I? Oh, yes. Even in directional wells, the driller starts by drilling the hole as straight as possible to the kickoff point. Remember, he takes photographic surveys all along the course of the well to be sure he's drilling the well as planned. Let's assume that the bottom of this so-called straight well has actually drifted 4 degrees off vertical due east of the surface location. And now the driller is going to intentionally deflect the well. His plan calls for the next 30 feet of hole to bottom out 37 degrees southeast of its present position. Turning the deflecting tool while it's on bottom so that it faces the right direction is critical.
Well, this is where I come in. Just tell me where you want to go, and I'll see what I can do for you.
Thanks, but we've developed some definite procedures for handling this situation.
Definite? What do you think I was going to...
As I was saying, the driller needs to know exactly which direction to face the deflecting tool and how far to angle it in order to reach the desired targets. To find out, he can use a complicated mathematical calculation called vector analysis. Or he can use a type of slide rule, or Ouija board as it's called, and a simple formula that makes things much easier. For this well, the Ouija board tells the driller to face the deflecting tool due south. By pointing the tool south, the next 30 feet of the hole will bottom out 37 degrees southeast. Now then, one of the most common ways for a driller to know which way the tool is actually facing is to take a survey using a survey instrument and a special sub called a mule shoe sub. One part of the sub is made up directly above the directional tool. This section consists of a sub body, a mule shoe sleeve, and an orienting key. The position of the key is adjustable. The key is pre-aligned to match the tool face. Then it's tripped in the hole. Next, the crew makes up a survey instrument and a mule shoe stinger and lowers them into the hole on a wire line. The stinger has a beveled receiving slot shaped like a mule's shoe. And the survey instrument has a camera, a floating compass, and a line called a tool face indicator. The indicator is pre-aligned with the receiving slot of the stinger. When the stinger and survey instrument are lowered into the drill stem, the receiving slot automatically slides over the key until the key and slot are snug. Once the key accepts the stinger, the driller knows the directional tool, orienting key, and tool face indicator all face the same direction. Then he takes the survey. The photographic disc from this survey instrument shows the position of the floating compass and the tool face indicator. The geographic poles appear at the top and bottom of the disc. The tool face indicator shows that the tool is facing 45 degrees northeast. Since the tool should face due south, the driller turns the tool clockwise 135 degrees. Sometimes a special survey instrument called a steering tool is used with a mule shoe sub. The steering tool barrel sits in and locks in position inside the mule shoe sub. Continuous information on the angle and direction of the well is then sent to the surface on a conductor cable. By reading a surface readout meter attached to the cable, the driller keeps a constant check on the angle and direction of the well. It's an excellent tool to see if reactive torque has been properly accounted for, and it saves time by eliminating the need for single surveys.
Well, now you boys are thinking. You can't count on me all the time. I could get tied up elsewhere, you know.
That thought had occurred to us, Gerhardt. New methods of measurement and new types of tools are being developed all the time. In fact, there's another method of controlling deviations that we need to discuss.
New developments? Tools? Oh.
Yes. One method is called measurement while drilling, or MWD, and it's being used more and more frequently offshore.
Let's see now, a measurement while offshore, what would that be under? Here it is. Measurement while drilling, MWD. Well, geological and engineering measurements are transmitted to the surface via mud pressure pulse telemetry. Oh, well, what in the hell is this about?
What that means, Gerhard, is that we can now obtain information on the direction and angle of the hole without using a wire line. Instead, we use the mud or liquid drilling fluid.
Yeah, I see that.
Instruments inside the MWD tool sense the direction of the well bore, the angle of the hole, and the tool face. The information is then sent to the surface on mud pulses, much like music and voice broadcasts on radio. At the surface, the information is processed by computer to give the driller an instant readout on what's occurring downhole. It's a very efficient system since no extra trips need to be made. This system, plus more advanced tools that are being developed, make directional drilling more accurate and less time-consuming.
Perhaps I could read some of this new material. I must keep up on the latest teaching.
Good idea, because in addition to these sophisticated downhole drilling tools, the driller needs a couple of other things.
Well, like what, for instance?
Well, for one thing, he needs a large pump when drilling directional wells. A powerful pump helps keep the downhole motor operating efficiently. The driller should also pay attention to the type of drilling fluid he uses.
Oh, yeah, the right drilling fluid or mud reduces friction downhole. And it helps keep the drill stem from sticking in the well bore. And keeps the cuttings in suspension away from the low side of the hole.
Oh, that's right, Gerhardt. Pretty good for an amateur.
Amateur? What was that? I am amateur.
No, not really, Gerhardt. Really, you've been very helpful. Just remember, drilling directional wells takes special processes, special equipment, expertise, and precise information.
Yeah, but think of the possibilities for you.
That's right. Directional drilling helps us overcome surface problems that straight-hole drilling just won't solve.
And helps you develop all those petroleum deposits that would have been unreachable for you. Nice work we did here, don't you agree?
Well, not bad. Thanks, Gerhardt.
It was nothing. I was just...
What? What was that?
Oh, it was nothing. It was the least I could do for a friend.